Okay, today I'm going to be showing you how to simplify exponents, whether it has division, multiplication, whether it's a fraction or it's a negative exponent. So, if you don't know what an exponent is just the number multiplied by itself how many times, right? So let's say we have 2 to the power of 2. This is, okay, 2 to the power of 2, right? This is our exponent right here. And what it's telling us, it's 2 multiplied by itself 2 times. So 2 times 2, right? So 2 times 2 is equal to 4. So 2 to the power of 2 is equal to 4. And you have to know this basic rule, what are exponents, so you can move on, right? Anyways, so if it was 2 to the power of 3, you'd multiply, okay, so 2 to the power of 3, you'd multiply 2 by itself 3 times. So this would equal 4, and then 4 times 2 is 8, right? So here we'd get 8, right? So that was hopefully you understand what an exponent is. So in algebra, we might face like a variable with an exponent. So let's say, what is x to the power of 2 times x to the power of 5, right? How do we simplify this, right? They have different exponents and all of this. Well, we can just add these exponents, right? We can just add 2 plus 5. So what we get is x to the power of 7. And you might be wondering, why? Because remember, x to the power of 2, so this is x times x. And then here we also have x to the power of 5. So x times x times x, and then times x, and then here's the final x, right? And if you add these up, you get 7. So, you get 7x's. And then, so x multiplied by itself 7 times is equal to x to the power of 7, right? So, here's the first rule, okay? When it's x times x to the power of, let's say, y, these are variables just in case, times x to the power of, I don't know, z, it's going to equal to x to the power of y plus z, right? So let's say, and this is like y was 3 and this was like, I don't know, 5. You would add 3 plus 5 and you would get 8, right? So yeah, this is the first rule. So this is the first rule right here. Okay? If you have x with an exponent times x, another x with an exponent, you can just simply add the two exponents and you would get the result. All right, let's erase all of this. Hold up. Okay, there you go. Now, how about, what if we have x to the power of 5, x to the power of 5 divided by x to the power of 2? Well, what you can do here is actually subtract this by this. So you might be asking, why do we do this? So this is x to the power of 3. This will equal x to the power of 3. Remember, so let's say we have here 5 x's. So x times x times x times x. And then here's the fifth x, right? And this is over x times 2. So here, x times x. And what you can do is just cancel these x's out, right? We have two x's here, and we can just cancel them out, right? So now we have three x's left. This is why this is equal to x times 3. So when you see two variables, like the same variable, and they have different powers or over each other, you can just subtract the top one by the bottom one. 5 minus 2 is equal to 3, right? So let's move on to the other rule, right? So this is the rule of this. All right. So another rule is, what if we have x to the power of 0? Well, anything to the power of 0 is going to equal to 1. Let's say we have, I don't know, 3 to the power of 0 is going to equal to 1. 4 to the power of 0 is going to equal to 1. I don't know, 254 to the power of 0 is going to equal to 1. Anything to the power of 0 is equal to 1. So keep that in your mind. Anything to the power of 0 is going to be equal to 1. All right. Uh, there we go. That's another rule we have to know about exponents. And then, uh, what if we have here x to the power of 3, x to the power of 3 to the power of 2? So now we even have a higher power over this, right? So what can we do right here? Well, we can just multiply these two exponents together. So we will have x to the power of 6. This is another law. So when you have a higher exponent here, other than this one, you can just multiply the two exponents, right? So Let's say also here we have x to the power of, I don't know, 2 to the power of 5. We can just multiply it, and we would have x to the power of 2 times 5, which is x to the power of 10. There we go, right? So yeah, and let me just erase all of this. Now, what if we have here 2 times x to the power of 3, right? So how would we do this? Well, we have to distribute the power. So we have to distribute the exponent. So we have 2 to the power of 3 times x to the power of 3. And then here, we can just, 2 to the power of 3 is going to equal 8, right? So here is equal to 8x to the power of 3. Nice. And let's say we have this other example, 6 times x, 6 times x to the power of 3 to the power of 2. What do we do here? Here we also distribute. So here we have here, and then we do here. And then here we have, so first of all, we can just separate. So it's going to equal 6 to the power of 2 times x to the power of, so x, 2 times 3. So remember, you just distribute by, you multiply it. Remember, yeah. And then you have times x to the power. So times x to the power of 6. And then you can simplify this. 6 to the power of 2 is going to equal 36. And then x to the power of 6 right here. Also, one thing to note is that if you have, let's say, like 5, it has a hidden exponent of 1, right? So it still has an exponent. So if you got to distribute, remember, it has a hidden exponent of 1. So you can just 2 times 1 equals 1. And then here you have it like that, right? And then, what if we have a negative exponent? So this is, well, I think the final law for exponents here, and then I'll be showing you how to solve, more and more, how to, I mean, simplify more complicated ones, right? So I'll be showing you through that. So let's say we have x to the power of -3. How would we be able to solve this? Well, you can just flip x, and then add the positive exponent. What I mean by this becomes, so this, remember, this is x over 1 technically. You flip it, so flip. And then you have x, 1 over x. And then here to the power of -3, you can just make this a positive now. This is how you simplify a negative exponent. Remember, when you have a negative exponent, make it like this. Let's see another example here. So, yeah, 4 to the power of 2, let's say. 4 to the negative power of 2. 4 to the power of -2, right? This is not the thing, but you can still simplify it. You will get 1 to the 4, 1 over 4. Remember, you have to flip 1 over 4 to the power of 2. So, when you have a negative exponent here, you can just flip the thing, and then you would get your result. Also, let's say if it was, let's say 3x, or hold on, x over 5. And this x is to the power of, let's say, -2. How would you solve this? Well, remember, you still have to flip it, even though there's the thing. So you get 5 over x to the power of 2, right? Anyways, let's start solving more complicated exponent, simplifying, I mean, more complicated exponents, I guess, expressions. All right. How about we have x to the power of 5, x to the power of 5 times x to the power of 6, or y to the power of 6, the power of 6. And then x times y to the power of 2. Right here, remember, in this case, we have to subtract, remember? So we have to subtract the top one by the bottom one. So 5 minus 1 is just going to equal 4. And then 6 minus 2 is going to equal 4. So what you will get here is x to the power of 4 times y to the power of 4. Y to the power of 4. One more thing I have to tell you is, when it comes to exponents, let's say we have here negative 2 to the power of 2. What would this equal? Well, we know that um it's negative 2 times 2, right? So we'd get negative 4. But what if we have negative 2 to the power of 2 in parentheses? This would actually be negative 2 times negative 2, because we can two negatives here, and then we would end up having 4. So just remember, if it's not in parentheses, it would be negative, and if it is in parentheses, it would not be negative. So yeah. Anyways, let's continue by solving more, and I will give you examples to solve right here. So let me just purge this, I guess you could say. Anyways, so I'm gonna make you do 3 questions here. You can pause if you want to solve them. 5x, so 5x to the power of 3, so 5x to the power of 3 times y over 16x times y, 16x times y to the power of 4. Y to the power of 4, and then here you can put, I'll put this in parentheses, and I'll put it over to the power of 3. So, and then let me just do another one. So, 2x to the power of 3, and then let me just, yeah, in parentheses, that is. 2x to the power of 3 times y to the power of negative 3. 3 to the power, okay, hold up, to the power of negative 2. Right? Pause the video and try to do these 2 examples. Come back and then see if you have them correct. All right, so let's solve the first one. All right, so 5x to the power of 3. So first of all, we can start by distributing, or we can just simplify this and then distribute. I will just simplify this first and then distribute the exponent. Or yeah. So let's start. Okay, so if we have 5x to the power of 3. We can first of all, remember, we still have to divide these. Remember, so we still have to minus them. So you get 5 over 16. So hold up, 5 over 16. 16x to the power of 2, right? Because we minused the 3 by 1. Right? And we still have to divide. And then we have y divided by y to the power of 4. And then y over y is just 1. 1 to the power of 4 is just 1. So what we end up having is 1 right here. All right, so we end up having, let's just like this, 5 over 16 to the x to the power of 2. Put this in parentheses. And then times 1. Times 1, yeah, and then to the power of 3. Now, we have to distribute this exponent, so you have 1 to the power of 3, which is still 1, and then x, 3 times 2, which is x to the power of 6, so times 1, and then here we have 5 over 16 to the power of 3, I think, yeah. Which you could solve for this. I have no idea what it is. I had to use I would have to use a calculator for this, but once you simplify it, you would get your answer. All right, let's solve for the second equation right here. 2x times y to the power 2x times y to the power of negative 3 to the higher power of negative 2. So first of all, let's multiply negative 2 to negative 3. So we have 2x. Also, we have to distribute here. So I have 2x. We would have 2x to the power of negative 2 times y. And then if we multiply negative times negative, we end up having positive times y to the power of 6 here. And then we got rid of this. So now we would just simplify this negative 2x. So we'd have 2 hold up. So we flip it. So yeah, it would be 2x to the power of 2 over 1 and y to the power times y to the power of 6. And then you would yeah, you would get the answer here, and then that's it. So I do hope you understood the this lesson.